Welcome to another edition of ProSoft Technologies video training. During this training session, we'll be working with the 5204 SE-MNET-PDPM V1 ProLinx Communications Gateway. The 5204 SE-MNET-PDPM V1 is a Modbus TCP IP to PROFIBUS DP V1 communications gateway that allows the Schneider Electric M340 PLC to easily communicate with PROFIBUS slave devices. In the ProSoft Configuration Builder setup portion, I'll show you how the PCB software will generate the defined function block file that contains all the required logic for the M340 to communicate with the ProLinx gateway. Also in the PCB setup section, not only will Unity users see how this can save time, but I'll also show you how easy it is to use. And lastly, we'll touch on the acyclic pass-through capability of the module. Okay, specifically during this training session, we'll have a PC running the ProSoft Configuration Builder and Unity software. PCB will be used to modify the configuration of the ProLinx unit, and Unity will be used to modify the M340 CPU logic. I'll demonstrate successful communications of the M340 communicating to the PROFIBUS slave devices. These slave devices will be an EM277 slave adapter for the S7200 CPU and a Phoenix Contact IL-PB BK PROFIBUS slave I/O block. Alright, now that you have a good understanding of what this training session is going to cover, now let's move into the PCB setup portion where we'll configure the ProLinx unit and the various slave devices that we'll have on our PROFIBUS network. We'll also export the required Modicon M340 PLC files. So let's go ahead and do that now. Alright, let's get started with the setup. First thing we'll want to do is open your favorite browser, and then go to prosoft-technology.com, and then here we're going to verify that we have the correct version of PCB, or the latest version of PCB. So we'll go over to Products, ProSoft Software, and click on ProSoft Configuration Builder. And when that page opens, on the top right-hand portion, or close to the top right-hand portion, we'll click on ProSoft Configuration Builder. And then here we can see the current released version. So just download the current release version, install it, and then you'll be ready to go. I'm going to close my browser now, and now we'll go into the PCB setup. Alright, I'm going to launch ProSoft Configuration Builder. And once PCB opens, you'll notice that it opens the last project that was used. So at this point, we can create a new project, or we can just add to our existing project. And you'll notice that it has a standard menu system above, but we're not going to really use that file system or that menu system. What we are going to use are right clicks and submenus of right clicks. So now I'm going to right click on default project. I'm going to choose to add a project, so add project. Now we'll give our project a name. Now I want to right click on the project I just added. I'm going to choose to add location. And now I'll give the location a name. Now I'll right click on the location. I'll choose add module. Under new module, I'll right click and I'll choose module type. And you'll notice that it has a few filters in here. Depending on the bullet you select, it'll actually filter it to the product style that you want. And I know that I want the ProLinx 5000 series, so in the little search box here we can quickly search for the unit that we're looking for, and I know mine begins with 5204, so I can type that in there, and I'll scroll down to 5204 SE-MNET PDPM V1, and you see that it's been added. Now you'll notice we have some red X's. Well, these red X's simply mean that we haven't configured anything yet, and hopefully when we're done we'll get rid of those red X's. Now I'll expand my PDPM V1, and notice down here it has a client section. Well, the MNET driver on this particular ProLinx has client functionality, or what's commonly referred to on Modbus as master functionality. We're not going to touch on that for this training session. What we're going to focus on is the server ability of the module and passing data from the M340 to the PROFIBUS slave devices. So again, the client functionality is there, we're just not going to touch on it during this training session. And under the MNET server section, you'll notice that it has a float flag no. Well, the unit can still handle floats. Just because the float flag is set to no doesn't really mean it cannot handle floats. It just means that it handles them a different way. The float flag is typically used for Enron style floats. So in the MNET server section, I'm going to go ahead and leave everything to default. Notice that in the tree, all the sections expand. Well, any one of these sections you can double click on. So I'll double click on the PROFIBUS Master DPV1, and you'll notice that it opens an edit window. Well, the other items are just the same. Anytime, whether it's MNET server, MNET client, if you double click on any of these, it'll open up an edit window for that particular setting. In the Edit PROFIBUS Master DPV1 section, I'll quickly describe a few of these parameters. As I describe these, and as I click on each one of these different parameters, notice on the right-hand portion there's a definition box. Well, as you click on any one of these items on the left, well, that definition box will update and display the information accordingly for what you've clicked on. Okay, so the first one, PLC Input Start Register. This is where the M340 needs to look for getting input data from the Profibus network. For instance, if I have an analog input reading into address 0 on the Profibus network, then the M340 could issue a Modbus read function code to get that analog input value. We'll talk about that a little bit later when we get into the Unity configuration. And actually, there are no Modbus commands to configure. Everything's done automatically. Okay, so the second one, input data size. This is how much input data we'll be using on our Profibus network. PLC output register start. This is the starting location for output registers going to the Profibus network. So for instance, if the ProLinx unit is writing an output value to an analog card at address 1000, then the M340 can write a Modbus function code to address 1000 to overwrite that value. And again, in the Unity setup you'll see a little bit later, you'll notice that we don't have to add or modify any Modbus function codes or registers at all. And the output data size, that's the number of registers the Profibus master will be writing to the Profibus network. And input and output byte swap. This allows you to swap the input and output bytes of the individual words. Mailbox messaging. We're going to keep this on yes, and we're going to keep slave diagnostics on yes. We'll be touching on the mailbox messaging a little bit later. PLC status start register. This is the starting location where status information will be stored. Watchdog register. Right now we have this value set to -1, which means that the parameter is not being used. With the value set to 1, when the watchdog is tripped, all output values will be written to the watchdog reset value. So whatever value we have in the watchdog reset value, well, the outputs will be set to that value if the watchdog register parameter is set to 1. And then we have the watchdog timeout, which is pretty self-explanatory. And up above, we have a comment field. Here's where we can add a comment for the module. So we can double click on it just like all the others. And here we can add a module comment. We have a common net section, which I'm not going to touch on during this training session. So please refer to the ProLinx PDPM V1 driver manual for more information on what the common net functionality does. I'll tell you real quickly that it allows you to map and remap registers to different locations. So for instance, on some of our products, we have status information that is above the user data. So essentially your protocol has no access to that register. What the data map allows you to do, it allows you to map that status information into your user data. So now you have status information on each protocol. Again, we won't be touching on that during this training session. And here we have the email section. Here's where you could set up a register or a group of registers that when a particular value is met, you can have the module email you the particulars on that value. Keep in mind that on some corporate networks, this may not be allowed. So I'd certainly check with your network administrator to get assistance on setting this up. And again, we won't be touching on this during this training session. Now we have the Ethernet configuration. So I'll double click on Ethernet configuration and it'll open up my Edit Watt TCP section. Now here's where you want to type in the IP address that the ProLinx gateway is going to use. So here I'll type in the IP address and then modify the net mask if needed, and then modify the gateway, and then click OK when finished. Now we'll work on configuring our Profibus network. I'll double click on PROFIBUS DP and then configure Profibus. Alright, when the PCB Profibus configuration window opens, first thing I'm going to do is I'm going to go into the properties of the Profibus master. I can double click on it and I'm going to change the Profibus parameters. I'm going to set my master to use node 0. I'm going to change my baud rate and I'm going to leave everything else at their default value. And then click OK. Alright, so at this point I already have my Profibus slaves defined within the configuration utility because I've already imported the GSD files. So if you have slave devices that are not listed in the I/O tree or in the Profibus DP tree, then you'll need to install the GSD files. So you can click on Tools, Install New GSD, browse for and select the particular GSD file you need to install. And then once you install it, it'll be listed in the tree. On with the configuration. Alright, so I'll drag over my first Profibus slave, and this is a Phoenix Contact I/O block. Now you notice with the Phoenix Contact module, it is an I/O block, so each one of those little colored slices you see there, those are actual I/O modules. So now what I need to do is in the Profibus bus terminal setup, I need to add each individual I/O module. So what I'll do at this point is expand this particular slave, and now I'll scroll down and select the individual I/O modules for my unit. I know that the first one is an IBIL DI8, which is an 8-channel digital input, and the second one is this 2-channel analog input, and the last one is this 4-channel digital output module. So there, I've got all those mapped over, and now I'm going to double click on the slave and I'm going to set the node address or the Profibus slave address for this particular unit. For this one I want to use node or slave address 13. And depending on the particular slave that you have, it may have parameter assignments that you might need to modify. For this particular slave that I'm using, I don't need to modify anything, so I'm going to leave the defaults as they are. Now I'll click OK here, and now I'll add my second Profibus slave. I'll scroll down to PLC and I'll choose my EM277 and drag it across, and now I'll double click on it and I'll set its Profibus address to 1 and then click OK. Now the same thing goes true for this. Now I need to map in I/O. This doesn't really have I/O assigned to it. It has data words for communicating to and from the CPU. I'm going to go ahead and select 32 word out and 8 words in. There, so I got that mapped in. Now I can close this section and choose to save it. Now I'm going to export the files that we'll use later in Unity Pro. Keep in mind that when exporting these files, the new application communication logic functions built into ProSoft Configuration Builder automatically generate all the Unity Pro data types, variables, and logic required for the M340 to perform Profibus DP cyclic and acyclic communications. These files import into Unity Pro version 4 software without any modification. This completely eliminates the need to write any additional communication logic, and I'll demonstrate this in the next section. And now I'm going to click on Show ProLinx Memory Map, click on Export Processor Files, and I'm going to use this name for now. Click Save, click OK. Now I'm going to click on Export Master Config, and I'm going to use that name. Click Save, and then click OK. And now the last thing we need to do is download the configuration to the module. So I'll right click on my module name, MNET-PDPMV1, choose Download from PC to Device, and it's going to scroll through your available serial ports and then show the Download Files window. Now there's a couple different ways to download. You can download via a serial port or you can download via Ethernet. If you know the unit's IP address, then you can download via Ethernet. If you don't know the unit's IP address, then you can download via serial. If it's a new module, then you can click on the Use Default IP button, change your PC to that subnet that you see on your screen, and then download that way via Ethernet. But I'm going to go ahead and use serial. Initially, you probably want to use serial since you may not know the IP address if it's a new module, and you don't have to modify IP settings on your PC, so I'm going to choose serial, select my COM port, and click download. And on the top, you'll see the download status. And the last thing you'll see in the download status is you'll see module rebooting, and then lastly, module running. And at that point, you can go ahead and click OK, and we're finished downloading. Now the module has its new IP address, has its new configuration, and in the next section, we'll configure the M340 using Unity, and during that section, we'll import the files that we just exported. So let's go ahead and do that now. During this section, we're going to configure Unity for the M340 to communicate to the PROFIBUS slaves. So let's go ahead and launch Unity now. I'll click on New to create a new application, and I'll select my CPU. I'm using the M340 with Modbus Ethernet. Click OK, and there my application is created. The very first thing I want to do is import the files that I exported from PCB. So I'll click on the Functional View button, right-click on Functional Project, click Import. I'm going to click No to save changes. I don't need to save them just yet. And now I'll browse for and select the functional module file, or XFM file, that I exported with PCB. So I'll select that file, I'll click Import, and there you see file has been imported. Now I'll click on Structural View, right-click on Variables and Function Block Instances, choose Import. Again, I'm not going to save this. Choose the XSY data file. And now in here, I'm going to go ahead and click on the Replace All button, and then click OK. And there you see all our data types have been imported. Now right now, I'm going to go ahead and compile this just to show you that there are going to be quite a few errors initially. And I'll show you how to get rid of those errors. So click on the Rebuild button, and you're seeing it's rebuilding the entire project, and we have 95 errors. So now let's go ahead and take a look at a few of these errors. And here's one error that I know we can get rid of. It's the usage of dynamic arrays is disabled. So from here, I'll click on Tools, then Project Settings, click on the Language Extensions tab, and then click the Allow Dynamic Arrays checkbox, and then click OK. And then once I do that, I'm going to go ahead and rebuild the project again. Now we only have 3 errors. Now we need to configure the internal memory of the M340, and I'll go ahead and do that now. In the project browser, let's expand Configuration, then expand PLC Bus, and then we'll double-click on our CPU, and then from the PLC Bus, we'll double-click on our CPU. And now I'll zoom in to the Size of Global Address Field section, and now I'm going to change the internal words to 3000 to make room for the data that we configured within PCB. Now I'll close this section and choose Yes to save my changes. And now once again, I'll rebuild the project. And now we see, finally we have 0 errors and 0 warnings. So everything should be good to go. Now what I'll do, I'll configure the Ethernet port of the CPU so we can download our application. So I'll right-click on Networks, I'll choose New Network, I'll choose Ethernet, and I'm going to use the default name Ethernet 1. Click OK, choose Yes to save the modifications. Now I'll double-click on Ethernet 1, and now we'll select the CPU that we're using and choose Yes to confirm. Now in the bottom section here, I'll modify the IP settings that I want this unit to have. And once all that's finished, I'll close it, choose Yes to save my changes. Now what we'll do, we'll scroll up to the top. We'll go up to our rack. We'll expand our communication ports. I'll double-click on Ethernet. Now I'll click on channel 3, and in the function drop-down, I'll choose Ethernet TCP IP, and in the link, I'll choose the Ethernet 1 network that I created. I'll rebuild the project. Once I click yes, you'll notice that we have an error. That's because I haven't closed this window and saved the changes. So I'll close this window, save those modification changes, rebuild it again, and once again we're back to 0 errors and 0 warnings. Now we should be ready to download our application to the CPU. Now it's telling me that I haven't set the CPU address, so I'll click on PLC, set address. Now I've already downloaded an application. I've already changed the IP address using the USB port. So since I've done that, I'm going to go ahead and use Ethernet to download. And I'm going to type in the IP address that the PLC currently has. I'll click the test connection button and then click OK. Now I should be able to go online. And you see here that the online project and offline project are different. So now I'll click on Download Project. And I'll click on the PLC Run After Transfer checkbox. And then click on Transfer. Click OK. Now you see that the transfer is going through. And I'm going to click OK to run the project. Now you see that the PLC is in run. Everything's green, everything's happy. And now in the next section, what we'll do, we'll go in and we'll take a look at some animation tables, and we'll show how the M340 can change values on the PROFIBUS slave devices. And we'll also look at some status information within ProSoft Configuration Builder. So let's go and do that now. Okay, in this section, we're going to take a look at how data gets passed from the M340 PLC to the PROFIBUS slave devices. So let's go ahead and get started. First thing I'm going to do, I'm going to take a look at some animation tables. And the two primary animation tables that I'm going to look at are the MNET PDPM V1 basic variables and MNET PDPM V1 mailbox variables. So as I expand the MNET PDPM basic var, we see that we have read cyclic data, write cyclic data, module status, and PROFIBUS slave diagnostics. And under the mailbox var, I'm not going to read off each one of these. What I'm going to do in here is just touch on a few of these. So to get a complete description of what each one of these mailbox functions do, please review the PDPM V1 user manual. All right, what I'm going to do at this point is I'm going to open up ProSoft Configuration Builder, and I'm going to go ahead and leave Unity Pro open. And I'm going to set my screen up to where we can see the PCB on one side and we can see Unity Pro on the other side. So as I change a value within Unity Pro, we'll also see that value change on the PROFIBUS slave. Bear with me just a few seconds while I set that up. Just about there. I'm going to drag this over just a little bit more. All right, perfect. Now we have ProSoft Configuration Builder on the right and Unity Pro on the left. Now in PCB, I'm going to click Online and then Monitor Modify. And now that's going to go online to the ProLinx PROFIBUS Master. And once I go online, you can see that the two slave devices are highlighted green, which shows effective communications to the master. Now what I'm going to do is pull the PROFIBUS cable from node 13, and you'll see that it turns red. I'll plug it back in, and you'll see that it turns green again. Now over in Unity Pro, I'm going to go over to the mailbox function set operate mode. Now the set operate mode, what that allows you to do, that allows you to stop passing data to all slave devices. So let me go ahead and do that now. So I'll click on stop. I'll click on the send 1 button. So essentially that sends a 1 to that value. And once I do that, you see both PROFIBUS slaves turn red, which shows that they are no longer communicating to the master. Now if I double click on the master, it brings open an online master properties window, and it shows the status of the two slave devices. If we had more than these two slaves, then it would show those in this window as well. And you can see in the far right column, the status column, both devices are showing false. Now I'll click on Operate, send that a 1, and now you see that they're both running again. So now they're both effectively communicating to the master again. And in our PCB setup, we see that the status column shows OK for both slaves. I'll now expand the getLiveList mailbox function, expand the out parameter. I'll click getLiveList, and then I'll send that parameter a 1. Now I can expand the in parameter, expand stations, and here we can see that node 0 has a value of 3, which indicates a master. Node 1 has a value of 0, which indicates an active slave on the network. And node 13 also has a value of 0. And all the other nodes have a value of 4, which represents a non-active slave. Now I'm going to expand the basic vars. I'll expand module status, expand the out parameter. I'll send get module status a 1, and that brings in the module status. Now with these parameters, we actually have to map in some other animation tables. So at this time, what I'm going to do, I'm going to import a few more animation tables. So I'll click in the field, click the import button, and now we select the animation tables that we want to import. So I have slave diag and outputs. I'm going to import those, and there's one more I want to import, and this status import. Let's import that one. Okay, so if you remember, we clicked on module status. Now if we expand MNET PDPMV1 status in, we'll see that all the parameters show the values that we had previously configured within ProSoft Configuration Builder. So it gets the status of the module. Now we're going to pass some values from the M340 controller to the slave devices. And we're going to do this by using the write cyclic data parameter. So over in PCB, now I'm going to show you how the data gets mapped from the different I/O or different slaves into the PROFIBUS master and ultimately into the M340 controller, and vice versa, out from the M340 controller into the master, out to the slave devices. In ProSoft Configuration Builder, I'll click on Show ProLinx Memory Map. I'll click on Outputs, and now I'm going to bring in an image of the unity map that I'm using. Notice the L and the H in the start address and end address columns. Well, that L and the H represents the byte of each individual memory location. In other words, where you see start address MW1000L, well, that means that the starting address is at memory location word 1000 low byte, and the end address is memory word 1001 high byte. But the module we're particularly interested in is the 4-channel digital output module, which is the second memory mapping that you see there. So it's telling us that it's mapped to memory word location 1002 low byte, and it ends on memory word location 1002 low byte. So that means that it's only using 1 byte of data. Now if we look at the red highlighted section, that's byte number 5 on the M340 CPU. So when we manipulate values within that byte, we'll manipulate outputs on that slave device. And we'll show that now. Okay, back to our split screens. On the left again we see Unity Pro, and on the right we see the PCB software, and I'm currently online with the Profibus network. And now I'm going to double click on node 13. I'm going to position that just a little bit, and I'm going to double click on the DO4 module, and I'll position that, and we'll change the format to binary. And now in Unity Pro, I'll expand the PDPMV1 outputs, and remember we said byte number 5 is the byte that we want. And I'm just going to copy this and actually make it its own animation table. Paste it in there. And I'm also going to change its format to binary. Alright, so now we have our byte number 5. I'm going to change the very first bit. I'm going to go up to write cyclic data. I'll send that value a 1. And immediately you'll see that the output on the DO4 goes high. Now I'll change a few more outputs. I'll write the value to 1, and we'll see those values go high. Well, that about does it for this training session. If you have any questions about any ProSoft technology products, please feel free to contact us using the contact information you see on your screen. Until next time, happy training. Bye.